Hello everyone. This is our first example on our series of online lectures on torque. So in this example, the figure shows a force P being applied to one end of a lever of length L. So A, what is the magnitude of the torque of this force about point A? So we have three choices: P, L sine theta, P, L cosine theta, and P, L tangent theta. Recall that we have defined the magnitude of the torque to be the product of the length of the moment arm multiplied by the effective force. So in this case, we already know that the length of the moment arm is L. Now we want to determine what component of P is the effective force. If we are to redraw the object here, so this is rotation at point A, and this is angle theta here. P is pointing downward. So if we have our angle theta here, P is at an angle of theta in this direction. So recall that we have defined the effective force to be the force that is perpendicular to the moment arm. So if this is our moment arm, this component of P is the effective force, which is, if we write this inside the magnitude, this is P cosine of theta. So this is our magnitude of torque. Now for letter B, what is the direction of our torque? So from our intuition, we already know that this force P would cause our lever to rotate in this direction. But this direction is not the actual direction of torque. Recall that the torque is always on the axis of rotation. Okay? So by using our right hand rule, if we curl our fingers into the direction of the rotation, we would determine that the torque is pointing into the page. Sorry, this is into the page. So it's like an arrow with a tail that is going towards the page. So try to curl your fingers and you would know that your thumb will point towards the page. If the object were to rotate in the opposite direction, say counterclockwise, our torque would be out of the page. Now this is like an arrow that is pointing towards you or out of the page.